This video is about fundamental forces, but in a way you have not seen before. We start with the mighty superforce, which is made up of light speed c to the power of 4 and the gravitational constant g. Interestingly, dividing these two values actually results in a force. Next, we will talk about the first 4 fundamental forces, i.e., the electric and magnetic force, the gravitational force, the strong nuclear force, and their hidden relationship to the superforce that will reveal a new perspective and overlooked relations. Finally, we will talk about gravity again, for which a fascinating and unusual formula is presented. So, if this sounds interesting, stay tuned until the end and give this video a thumbs up. The only place in physics where you can currently encounter the superforce c to the power of 4 divided by g is in the general theory of relativity. There, however, this force appears in a reversed form, as part of a conversion factor between energy density on the one hand and space curvature on the other. Beyond that, the superforce, which is usually called the Planck force, has not received any attention so far. A serious mistake, as we shall see. The first thing to notice is that this force is extremely strong with about 10 to the power of 44 newtons. So strong that it is reasonable to assume that we are dealing here with the largest possible force in our universe. Only the strong nuclear force in atomic cores can reach this level, as well as the imminent collision of 2 black holes. Interestingly, it is nonetheless possible to express Newton's gravitational force as a function of the superforce if the two involved masses are expressed as energy. This exemplifies that Newton's gravitational force and Einstein's general theory of relativity are deeply related. Furthermore, I also consider the new formulation that uses the superforce to be more fundamental, as I think that, in the end, mass is a locally confined turbulence of space. The superforce can also be used to define a fundamental length, as the superforce can be written as a combination of the speed of light, Planck's constant, and a squared length. This allows to derive the so-called Planck length, which is so incredibly small that a number of physicists assume that this is the smallest possible length in our universe. Furthermore, this length plays an important but previously unknown role in physics, as we will see in a short while. Moreover, the second notation of the superforce raises the assumption that this force plays a greater role in physics than acknowledged so far, because there is no way more fundamental to define a force than by using light speed c, which represents linear motions, and the Planck constant h, which stands for rotational motions. This circumstance also suggests that the superforce was the first force in our universe, from which the other forces have emerged. We will now investigate that speculation further. In the table to the left, you see the main 4 fundamental forces, but in an unusual notation that, as far as I know, does not occur in physics literature, but which illustrates certain relationships that are not apparent with the usual formulations. Therefore, we are looking at a special case here, namely the forces between 2 protons, neutrons, or electrons, which all belong to the group of the so-called fermions and possess spin 1/2. These particles are the most important components of visible matter, as they make up the atomic cores. When looking at the formulas, the first thing to notice is that the usually used natural constants are missing, but the superforce and the Planck length are present in the formula for each force. Presumably, in the early universe only the superforce existed, and later on the other forces derived or separated from it as our universe cooled down. This common legacy is the likely reason why the formulas of these forces share a certain similarity, which incidentally also makes it easier to classify their relative strength. Furthermore, the strength of all these forces depends on how many Planck lengths fit into a certain distance d, which really highlights that the Planck length is likely a fundamental property of nature. At the bottom right of this video, you can see an equation which makes it clearer that the shown formulas actually state that the distance is divided by the Planck length. Having light speed c now appear in the formula for magnetism is also a sensible change compared to the standard formulas, because magnetism is all about motion. Moreover, later on another formula is presented for the gravitational force, which also fits nicely into the patterns presented here and even highlights why Newtonian gravity is weak compared to other fundamental forces. Before going into more details, I would like to emphasize on why these formulas are of importance for the big picture. In my view, the possibility to express these forces in the way shown here is not a mere coincidence or superfluous, but quite to the contrary, I consider these formulas to be more fundamental than the usually used formulas and to give us more insight into the wheelwork of nature. The use of the gravitational constant, as well as the magnetic and electric constant, however, do conceal insights from us. According to the view laid out here, these constants were only defined because the physicists back then didn't know about the aspects mentioned here. But now back to the analysis. The force that comes closest to the superforce is the strong nuclear force. However, the shown formula is only an approximation because the strong force does not decrease quadratically with distance d. But still this formula is quite applicable in the vicinity of a proton or neutron. In the case of the electric force, it is immediately apparent from the presence of the Sommerfeld constant alpha that this force is approximately 137 times weaker than the strong force. Furthermore, the Sommerfeld constant alpha is also present in the formula for the magnetic force, which shows that the electric and magnetic force are closely linked, whereby the magnetic force obviously depends on the movement speed of the charged spin 1/2 particles. In the shown formulation of the magnetic force, we are dealing with the special case that two separate charged particles move parallel to each other, as in that way, this intuitive formula for the magnetic force is obtained in which the relevant reference quantity, namely the speed of light c, is also evident. The formula shown for Newton's gravitational force is more difficult to classify. It contains the so-called Planck mass, which so far has been a mystery to physicists, as it has not yet been possible to assign any significance to it in established physics. At around 22 micrograms, the mysterious Planck mass is extremely heavy compared to the fundamental particles. In my opinion, the Planck mass is the mass or mass energy of the presumed quanta of space. But that is a separate topic, and in the context of this video, it is sufficient to note that the Planck mass is the relevant reference quantity for gravity. For the viewers who are still with me, I do have a surprise. Newton's gravitational force can also be expressed using velocities. However, the velocities used in the new formula are not the motion speeds of the masses involved, but their so-called escape speeds. The escape speed denotes the velocity that must be reached in order to fully leave the gravitational region of influence of a mass. Here, the reference quantity for gravity is again the speed of light, as with the magnetic force. This reference quantity makes sense because an escape velocity close to light speed c can only arise in the vicinity of a black hole. Furthermore, this circumstance also shows why the gravitational force is relatively weak. In the new formula, it is twice divided by the squared speed of light, which is a huge number. Incidentally, this gravitational formula is not limited to protons, neutrons, or electrons. It can be applied to all masses that can be idealized as point masses. But as far as I know, this formula for the gravitational force is not part of any physics textbook, at least I have never seen it. The reason why this formula works is because the physical units of squared speed correspond to those of a gravitational potential. Furthermore, the squared speed of light marks the physical limit for a gravitational potential, which can only be attained by a black hole. The speed of light, therefore, has a second important meaning in physics. When it is being squared, but this circumstance is not recognized by established physics yet. We have now reached the end of this video, and I think it has been convincingly shown that the superforce plays a central role in physics, and that some important fundamental physical relationships can only be revealed if the superforce is included. An important question in physics, for example, is whether all fundamental forces can be unified under certain conditions, and the so far ignored superforce is obviously an important component of such a unification. So, there is indeed still a lot to discover in classical physics, which I also point out in my scientific work and my book, Physics Recombined. Links to that material can be found in the description of this video.